Hi guys, this is Mr. Urrego, and today we're going to learn how to find the domain of a function. First of all, what is the domain? What is the domain about? So I have a couple of polynomial functions. Let me explain. The domain is nothing more than finding the values of x where my function is defined. When I have a polynomial function, I can plug any value. 2 times 2 is 4 plus 1 is 5. 0 times 2 is 0 plus 1 is 1. So it doesn't matter what values of x I plug in, I will get a value of y. Negative 1 times 2 is negative 2 plus 1 is negative 1. So every value of x that I put, I get a value of y. Remember, what is a function? For every input, you will get an output. So in any polynomial function, I can plug any value of x and I will get a value of y. That's the whole idea. Therefore, my polynomial functions, all of them, my domain is the set of real numbers. So that R means the set of all real numbers. Another way how to do it is interval notation, from negative infinity to positive infinity. So now we have polynomial functions, but where is this not going to work? Rational functions, they don't work. Rational functions, square root functions, a combination of those. So there's multiple times that I will have to find the restrictions to the domain. So let's start with rational functions. So the idea is to find the restrictions of the functions. One of the restrictions is when I have a rational function. If I have a rational function, that means I have a fraction. Now, can I have a 0 on my denominator? 3 divided by 0, undefined. Right? Every time I have a 0 on my denominator, then my answer will be undefined. If my 0 is on the top, then my answer is 0. So there's no problems with this. So because I don't want to have a 0 in my denominator, then what I want to do is I want to make my denominator 0. So I bring my denominator and I'll make it equal to 0. From there, I get a factor if I can factor. So two numbers that I multiply get negative 12, and when I add, I get 1. So x plus x minus, and my two numbers are 4 and negative 3. 4 times negative 3 is negative 12, 4 minus 3 is 1. So this is the factor. Now to find the values of x, each factor you make it equal to 0. And from there, I have to find the value of x, which in this case is negative 4. And here is going to be plus 3 on both sides, x equals 3. Now, the question is, do I want these values? No, these values will make my denominator 0. Therefore, I don't want them. Now, every time I'm doing the domain of a function, my default is all real numbers. And then I look for the exceptions. In this case, these two values are my exceptions. Therefore, I'll write x different of negative 4, and x has to be different of 3. This means I don't want these values. Now, if I want to write this on a number line, then my domain is all real. So all of them. But now, these are my exceptions. So here, I'll make a whole, negative 4, and 3. And those values will not be part of your domain. Okay? Empty hole here, empty hole there. If I want to write this in interval notation, then I start from the negative infinity all the way to negative 4. Because there's a hole, the negative 4 is not included, combined with between negative 4 and 3, combined with 3 infinity. So this will be interval notation for this. Let's work in another one. Now we have this rational function. Okay, same idea. I don't want a denominator equal to 0, so I bring my denominator and I make it equal to 0. And I'm going to try to find the value of x. But now what's going to happen here? Look, I have x squared equals to negative 1. If I do square root of this, I'm going to have plus or minus square root of negative 1. Can I have this? Can I put this in the calculator? No, this is an imaginary number. And remember, my domain, I work on the set of real numbers. Because this is not a real number, then there's no restrictions on my denominator in this case. Therefore, my domain for this function is all real numbers. Okay? That's a little trick. That's I want to address that. Okay, let's go to the next one. Now, what about if I have square root functions? What's the idea with the square root functions? Here, can I have a negative number inside a square root? No. If you have a square root of a negative number, like we just did, this is going to be an imaginary number, which is not part of the set of real numbers. And remember, my domain is the set of real numbers. So I need to find a value of here that will make the inside positive. So what I do is I take whatever is on the inside and I make it greater than or equal to 0. With this, I'm guaranteeing that this is going to be a positive value. Anything greater than 0 means it's a positive number. Okay, minus 3, x is greater than or equal to negative 3. So any value that is greater than negative 3 will satisfy this inequality. Now let's graph this. Negative 3. Okay, I'm graphing the inequality because it has an equal, then it's going to be solid. And the values that are greater than negative 3 are all the values to the right. Okay, let's write this in interval notation. Negative 3 all the way to infinity. Infinity will always have a parenthesis. Now, the negative 3 is included. Therefore, I put a bracket. Okay, this is interval notation. What if I write this in set notation? So it's going to be x such that, and I bring my inequality. X greater than or equal to negative 3, and I close. Alright, let's check another one. We have this one. Same idea. The inside has to be greater than or equal to 0. Solve for x. Minus 6, negative x, greater than negative 6. X cannot be negative, so divide by negative 1. Okay, inequalities. If I divide by negative, my inequality symbol will flip, will switch. Okay, will reverse. Negative 6 divided by negative 1 is going to be 6. So be careful with that. Now my inequality changed. So let's graph this. I have 6 here, is included, so solid or shaded, and the x has to be less than or equal to 6. Therefore, I'm going to the left. And now this is my domain. Now let's write this into interval notation. So the smallest values to the left is negative infinity, all the way up to 6. Infinity, always parentheses, here is included, so I put a bracket. This is interval notation. Set notation. X such that, bring the inequality. X is less than or equal to 6. That's it. Now, what we're going to do now is we're going to have a combination of those. And that's going to be the most confusing part. Having a combination of radical expressions and rational functions. So we're going to do square roots when the square root is on the top. Again, so basically you have to be careful with both. If it's a rational function, remember, can have a 0 in the denominator. Now, with these functions, you're going to have a lot of factoring, so make sure you review factoring. I will link it in the description. And the other exclusion or restriction is that inside the square root, it has to be positive. So let's do one at a time. So let's take this, x minus 1, and it has to be greater than or equal to 0. Okay, plus 1 plus 1, x has to be greater than or equal to 1. Now let's take the bottom. Now because I have the bottom, then I have to take x squared plus 2x minus 8 equals to 0. Remember, I don't want a 0 in my denominator. So let's factor this. Two numbers that you multiply with negative 8, and when you add or subtract, you get 2. So the numbers are 4 and negative 2. 4 times negative 2 is negative 8. 4 minus 2 is 2. Now every factor, you make it equal to 0. X plus 4 equals to 0. X minus 2 equals to 0. Minus 4, x equals negative 4. Plus 2, x equals 2. And these are the values that I do not want. So according to the denominator, my domain is all real except the values of negative 4 and positive 2. My numerator is all greater than or equal to 1. So let's graph this. my numerator is going to be this, 1 greater. My denominator is going to be all real, but I don't want the -4, and I don't want the +2. Okay, now, in order for the domain, or in order for them to be valid or legit, it has to work on both, right? So if you notice, basically we're looking for the intersection of those two domains. So let me explain. There we go. From here on, there's an intersection. Before, this graph is not on the top, therefore all this doesn't work. So the values that will be my domain will be all the values that are greater than or equal to 1. But now what happened here, my denominator has a hole at 2, so that's not included. Therefore my answer has to have a hole here. Therefore is not included to 2. So my final domain will be all real, such that has to be greater than 1, but the x cannot be equal to 2. And that's going to be my domain. Let's write that in interval notation. So this is the graph, all right? Combination of both, greater than 1, 2 not included. So interval notation, I start with 1, bracket. I go all the way to 2, not included, parenthesis. Then I jump to the other side. And then I start all again at 2, and then I go all the way to infinity. So this is the easiest way how to write the domain, okay, once you see it on the graph. This is my interval notation. If I want to write in my set notation, what I do is I just x such that, and I bring these inequalities, what I just brought over here. X has to be greater than or equal to 1, comma, but x has to be different of 2. And that's it. This is my set notation, and this is the interval notation. All right, let's go for another combinations. These combinations are the most difficult ones. Please subscribe to the channel if you haven't done so, please, and like the video. Comment, questions, or ideas for future videos, please. All right, let's go to the next one. Now, the previous one was the most confusing part. This is much easier, but again, we're combining both rational functions and radical expressions. Now my radical is in the bottom. What do I do? Again, let's start with the radical. Right? The inside has to be greater than or equal to 0. But hold on. It's on the bottom of a rational function, of a fraction. So can I have a 0 in my denominator? No. Therefore, I have to get rid of this 0. The equal cannot be. Can be equal to 0. Therefore, I take the equal out of it. Remember, I want to leave the x by itself, so plus 1, x has to be greater than 1. All right? So don't forget, when you have the square root on the denominator, you have to take the equal out of it. So now, that's it. There's no more restrictions. So my domain is x greater than or equal to 1 as a graph. This is the 1. Is included? No, not included. So it's open circle. And all the values from here. Interval notation. From 1 all the way to infinity. I'm sorry about my infinity, not too nice. Now this one, parenthesis or bracket. Parenthesis, that's right. Okay, so just in case the infinity is, there we go, something like that. It's an 8 sideways. Okay guys, don't forget to like the video, subscribe to the channel, ask questions in the comment section. Alright, I'll answer. Take care guys, I'll see you in the next one. Thank you for watching. Bye bye.